Alright, now it's time for the first joining of the mole concept and dimensional analysis. So we're going to start off with a softball, and we're going to ask you how many aluminum atoms are there in 3.5 dozen. Maybe you can do this in your head, that's okay. Not concerned with getting an answer, concerned with the process. So let's do it with dimensional analysis. Since 3.5 dozen is not a conversion factor, we're going to start with that. So 3.5 dozen. Going to do an X line, not thinking about it, closing one eye. What unit's going to go on the bottom? Yeah, a dozen. Why is dozen going on the bottom? Because it's on top. So dozen goes on the bottom. And what can we convert dozens into? Well, how about aluminum atoms? And the conversion factor there is 12 aluminum atoms for every 1 dozen. And what this is going to do for us is cancel out dozen, and now we're left with aluminum atoms. And we can solve this out and find out that in a dozen, or 3.5 dozen, there would be 42 aluminum atoms. That would be a very, very small amount. So let's kick it up a notch and bring it to moles. So how many aluminum atoms would there be in 3.5 moles? So 3.5 moles, that would be our starting point right there. So we're going to write that. So we've got 3.5 moles. And make our X on our line, and what's going to go on the bottom? Moles is going to go on the bottom, and moles we can convert into atoms, and that would be aluminum atoms, sorry. And then there would be, for every 1 mole, how many aluminum atoms? Yeah, that's right, 6.022 times 10 to the 23rd, Avogadro's number's worth. Moles is going to cancel out moles. We are left with aluminum atoms. And the question is asking us how many aluminum atoms, so we are ready to solve. And so as sig figs, our answer would be 2.1 times 10 to the 24th. And remember, no naked numbers. 2.1 times 10 to the 24th. We are left with aluminum atoms as our unit, so that means this would be 2.1 times 10 to the 24th aluminum atoms. Alright, I'm going to slide this up so we can see that last one a little bit better. So how many magnesium atoms are in 3.5 moles? We can do this one together. So 3.5 moles of magnesium. And there is, on the bottom, moles. So on top, we can do magnesium atoms. And for every 1 mole, there's 6.022 times 10 to the 23rd. Moles cancels out moles. We can solve this, and we find out that there's also, in 3.5 moles, 2.1 times 10 to the 24th magnesium atoms. So no difference there in the numbers. It's both 3.5 moles, so it's the same counting unit. So we're going to wind up with the same amount. We would have different masses, obviously, because aluminum and magnesium atoms are different sizes, but the same number. And these two types of conversions we just did right here, these would be what we call mole to particle conversions. We converted from moles into particles. Particles could be atoms or molecules. And these type of conversions always use Avogadro's number, and the conversion factor of 1 mole is 6.022 times 10 to the 23rd. Let's do something a little bit different now. So what is the mass of 3.5 moles of aluminum atoms? And mass is grams, and so we're going to have to convert from moles of aluminum to grams of aluminum atoms. And so our starting point here, 3.5 moles of aluminum atoms, that's going to be not a conversion factor, so that's what we can write as our starting point. So we have 3.5 moles of aluminum. And we make our X our line. What's going to go on the bottom? You guys are so smart. That's right, moles of aluminum. And what's going to go on top? Well, we want to convert moles into grams. So we don't necessarily know where we're going with it, but let's just go ahead and put grams up there to see what happens. So how many grams per aluminum? Do we have a way to figure that out? Yes, we do. The molar mass. So if we look at aluminum on our periodic table, we see that its molar mass is about 27.0. That means for every 27.0 grams of aluminum, you would have 1 mole. And so moles is going to cancel out moles. We're left with grams of aluminum, and we are ready to solve. And since our first number right there only has 2 significant figures, and that other one has 3, we can only have 2 significant figures in our answer. So that means we'd have 95 grams of aluminum. So 3.5 moles of aluminum would have weighed 95 grams. Okay, you try this second one. Find the mass of 3.5 moles of magnesium atoms. Give it a shot, and I'm just going to go ahead and do it off the video and show you the answer. And 3.5 moles of magnesium would weigh 85 grams. And so you're going to notice here, back in the last slide, we showed that 3.5 moles of aluminum and 3.5 moles of magnesium is the same amount of atoms, but they're different masses. And it's because it looks like aluminum is larger than magnesium. And so 3.5 moles of aluminum would weigh more than 3.5 moles of magnesium. All right, in this last one, I'm going to slide it up for it. So what is the mass of 2.34 times 10 to the 24th aluminum atoms? Ooh, so this one's a little bit different. We're starting with atoms, and we're going to mass. So rather than going from moles to mass, we're going to go from atoms to mass. So let's write down our starting point, which looks like it's going to be 2.34 times 10 to the 24th aluminum atoms. And then the unit on the bottom is going to have to be aluminum atoms. So we've seen our two conversion factors so far are grams to moles and from moles to atoms, but there is no atoms into grams directly. So this is going to have to be a two-stepper then. So we can convert atoms into moles, but we can't convert atoms directly into grams. And we know that 1 mole of atoms is 6.022 times 10 to the 23rd. And that makes it so that aluminum atoms cancels out aluminum atoms, and we're left with moles of, and I'm going to put aluminum there. However, it's not what the question asks us for. The question is asking us for mass, which means we're going to go another step. And we'd put moles of aluminum on the bottom, and then now we can go from moles to grams. So we can put grams of aluminum on top. And once again, we know that 1 mole of aluminum is 27 grams, 27.0 grams. And moles cancels out moles. We're left with grams of aluminum, so now we can solve this one. And to solve this one, do it on your calculator. 2.34 times 10 to the 24th times 1 times 27. And we're dividing that by 6.022 times 10 to the 23rd times 1. This number's got 3 sig figs. That one's got 4. That one's got 3. So our answer should have 3 significant figures. And we get 105 grams of aluminum. So if we had 2.34 times 10 to the 24th aluminum atoms, that is a lot of aluminum atoms, it would weigh 105 grams. Okay, so here's what we've seen so far. We can start with grams of something, and from grams we can convert that into moles, and we can actually go the other way as well. So we can convert between grams and moles, and then we can also convert between moles and particles. And particles would be either atoms or molecules. Just depends on the structure. So we can go from grams to moles and back. We can go from moles and particles to back. But we can't go directly from particles to grams. In order to get to grams, we need to first go to moles and then from moles to grams. So this is a useful piece of information. Maybe write it down in your notebook in the front. So we can go from grams to moles to particles. If you can remember this order right here, you can do any of the dimensional analysis problems that we're going to do in this unit. And then from this transition, from grams to moles or from moles to grams, that's where you use the molar mass. And so you go on your periodic table. So that would be the step that you use your periodic table for. And then to go from moles to particles or from particles to moles, that's where you use Avogadro's number. And so that would be the Avogadro step. Okay, another important thing to remember. So you never use the molar mass for that step, and you never use Avogadro's number for that step right there. Alright, so take a deep breath. Let's do some practice problems together. And if this still feels a little bit murky to you, I promise to you the solution to that is just to practice. Practice this enough, you'll get it no problem. In fact, I guarantee you with enough practice, there's going to be a point a couple weeks down the road where you're going to look back on this and say, it's the easiest thing in the world. How did I ever think this was difficult? All right, the first ones we're going to do is grams to moles. If you think you got this, if you feel like, okay, I think I understand this, pause the video and give these 2 questions a shot on your own. If you're still a little bit murky on this, go ahead and go through it with me, but I'm going to move through pretty quickly just so this doesn't turn into a really long video. Alright, so if we have 110.22 grams of calcium, write that down and we're going to convert it into moles, and we know that we can go directly from grams to moles. So whatever's on top goes on bottom, wherever we are going goes on top. And since the only thing that grams can turn into is moles, that means moles goes on top. And then that makes it so that grams cancels out grams. We're left with moles, and that's what the question asks for. So we can go ahead and solve this guy. And so since this number right here has 5 sig figs and that one right there has 4, our answer would need to have 4. So it'd be 2.750 moles of calcium. So 110.22 grams would be 2.750 moles worth of calcium. All right, and there's 213.0 grams of aluminum nitrate for every 1 mole of aluminum nitrate. Setting up like this would let moles cancels out moles, and I just took what's on top, which is moles, put it on the bottom, and where we're going, which is grams, put it on top. Since we can go from moles to grams, that means gram would go on top. We can solve this guy now. And 0.450 moles worth of aluminum nitrate would weigh about, with sig figs, so we need 3 of them, 95.9 grams. All right, let's take the other trail on the mole journey. So right over here would be like where the grams to moles is. Now we're just going to do from moles to particles and from particles to moles. So this is the back and forth. This is where we use Avogadro's number. So here's the 2 questions. Once again, if you think you got this, pause it, give it a shot. I'll move through these pretty quick in the video though. So in this first one, we are looking for atoms, and we're starting with moles. Since we've got moles on top there, we're going to put moles on the bottom, and we are going from moles to particles because it's asking about atoms, and so we can put atoms on top. And we know that 1 mole of anything, calcium or any other element, would be 6.022 times 10 to the 23rd atoms. And this makes it so that moles cancels out moles, and we can solve this. So 2.55 moles of calcium would be 1.54 times 10 to the 24th atoms. Okay, and for this next one, we had 4.07 times 10 to the 24th molecules. Since molecules is on top, molecules goes on the bottom. Molecules, which is a particle, we can convert into moles, and so I put moles on top, and it'd be moles of barium chloride. So now at this point, molecules cancel out molecules, and we can solve. And so then we come out with sig figs with 6.76 moles of barium chloride. Alright, now we can put it all together and do a complete conversion from mass all the way to particles. This is just taking those 2 little journeys, sticking them together, and we're going to do a whole bunch of jumble ones throughout the rest of this unit. And so getting used to kind of the process and remembering this setup right here is going to be key. That's the ticket. That's your golden ticket. Okay, so with this first one, we have 8.00 times 10 to the 20th molecules. The unit that's going to go on the bottom then has to be molecules because it's molecules on top. Then if we come up here, molecules is a form of particle, and so we're starting right here at this spot. From that point, from particles, the only place we can go is to moles. And so that's where we're going to go, and so that means the unit on top has to be moles. So we have where we were, where we're going. That makes it so that molecules are going to cancel out molecules. And then the conversion for that, that's Avogadro's constant that we use for this step right here. And so for every 1 mole, there is 6.022 times 10 to the 23rd molecules. The unit we're left with is moles in this case, but the question is asking us for grams, which means we're going to have to go another step. And so the unit on bottom is going to be moles, and then the unit on top, the only place we can go for moles, well, we could go back to particles, but that'd be counterproductive. So instead we're going to go forward to grams, and so the unit on top has to be grams. And 1 mole we would need to get for hydrogen would be 2.02 grams. And moles cancels out moles. Now we're left with grams. Now we are ready to solve. And even though 8 times 10 to the 20th is a very, very large number of molecules, hydrogen weighs very, very little. And so that many moles, or that many molecules, would only weigh 0.00268 grams of H2. And so that's it. You're really just following the units. If we started with molecules, that's what goes on bottom. Wherever we're going goes on top. And the only place you can go is going to be moles. So you put moles on top and then moles to grams. It's really just a process you got to get used to, okay? So if you're still a little bit muddy, like I said, practice. Speaking of practice, why don't you pause the video and give this last one a shot. Even if you're still a little bit muddy, just give it a shot, guys. Okay. So on this one, we started with grams, and we converted grams into moles by putting grams on the bottom to cancel those out, and then where we're going, which was moles on top, and then we had to convert moles into particles, and we did that by canceling out the moles, by putting moles on the bottom, and then putting particles, in this case they'd be atoms, since it's a single element, on top. And so now we are ready to solve this guy. So we would have 3.7 times 10 to the 24th atoms. Okay, and that's it. That is moles dimensional analysis that we're going to be doing for this unit. We'll take it a little bit farther next unit. We're going to do some practice with this just so we all get used to it. And hey, if this still seems a little bit unclear to you, that's perfectly okay. You are not the only one who's not going to get this right away. We're going to do practice, and I just encourage, I'm here to help you. So come see me before school, after school, ask me questions in class. I want to make sure that every single one of you guys understand this completely, so that when we move on to the next unit, or when you guys go on to college and see this again, it's not a problem for you. You've learned from talking to people who have taken chemistry in college that this is extremely challenging for them. If you can get this now, everyone can get this, then you won't have a problem when you get there.